recording. Here's my pep talk for this. This is solving the equations. We can do problems from now until doomsday, and I can't do a problem exactly like every single way that it could turn out. You kind of just have to look at them and see what you've got and like, what am I going to do with what I have here? I know that that's not what you guys want to hear, but you kind of just need to look at it and go, all right, what have I got here and what kind of method of approach could I use for this? You do get a calculator for them. You can't turn your back on these. This is where the bulk of the points is, because solving equations is a lot of steps. And so each step is worth a point. And so they're worth a lot of points. That's my pep talk for this. Okay. I always get everybody through it just fine, but you can't like turn your back on this. Okay. So for your exponential equations, we're going to do exponential on this side, logarithmic is on this side. So first method is try to get the same base on both sides. So when you look at number one, you need to be a good noticer. You have to notice, okay, I have an 8 and a 4. What's a base you could turn them both into, and it will be a smaller number. Good, perfect, 2. So I'm going to put 2 on this side. Now 2, think about your Quizlet that we play. 2 to what power will give you 8? Good. And then you see that 3x plus 1? You want to give that a hug, and it's sort of just there. Kind of just there. Equals, and then I want this side to also be a 2. That's the whole point. 2 to what power gives you 4? 2. And then that parentheses x plus 2 is kind of just there. So do you see how they're both 2? That means those cancel. And now you're back to an algebra 1 style problem. You would distribute this 3. What's that going to give you? Good. 9x minus 3 equals, and then over here, distribute the 2. 2x plus 4. Now, for the sake of time, I feel confident you could finish that up on your own. I'm going to just kind of like start every problem to make sure that we understand the material. But from there, I think you're good. Do you understand what I'm saying? I'll finish them when I post it to Schoology. You'll have all the answers. Okay. So let's look at this one. You have a 4 and you have a 1/16. What's a base you could turn them both into? 4. And do you see how this one already is 4? That's great. No work. Just copy that. Just copy that over. Hey, Miss Cole, looks like you just rewrote the problem. Sure did. There's a lot of that in math class. All right, on the other side, you want it to be a 4. 4 to what power gives you 1/16? -2. Good, negative because it flipped. Good job. So they're the same. They're going to drop out. You're going to have x squared minus 3x equals -2. Now, this isn't an algebra 1 kind of problem. This is more like an algebra 2 kind of problem. What do you do there? Evacuate. You're going to move over the 2, get it all on one side, and then factor it. So you'll get 2 answers. I will do the factoring part. What's that going to split into? Just to make sure we can factor. 2 and 1. Yep. X and X, 2 and 1. And they're both negative. So actually, I'll just go ahead and finish it. You would get +2 and +1. You got 2 answers for that. So that's kind of your first method, is just look at it and see like, hey, could I turn them both into the same base? All right. This one won't work like that. Why not? Why couldn't I make them both 2? Yeah, like 2 to what power gives you 7? Anybody? Okay. So the second method is you're going to log with the same base. And the point of that is that they'll cancel. Exponential and logarithmic are inverses. So you're trying to get it to cancel. It's no different than if, can you stop that? It's no different than if there's a +3, you would do -3 to cancel it out. Do you get what I'm saying? Okay. So for this one, do you see how that's a base 2? You are going to log base 2 both sides. You're doing log base 2 to both sides. What you do to one side of the equation, you do to the other. And what happens is that'll cancel that out. The log base 2 and the exponential base 2 cancel. So you get x equals log base 2 of 7. And I'm going to show you how to type that in the calculator. Also, I don't think we've talked about decimal points in here yet. I feel like this is like the first place we sort of come across that. I teach it according to AP Calculus's rules, whether you're going on or not, because some of you will. So here's the rule for AP Calc, and this is what we're going to follow. And it's not sig figs, okay? If you were starting to get nervous, it's not that. You have to do 3 decimal points, and you can do what's called truncating, which I call it the first 3 that you see. You don't have to round, you just take the first 3 that you see and cut it off. All right, so that's what I'm going to grade by. And if you don't do 3 decimal points, I'm going to take off because that's how they do it on the AP exam and blah, blah, blah. All right, so go ahead and pick up your calculator. You're going to go to the math menu, which math is right here on the left side. It's right below alpha. And now you can hit the down arrow, but it's actually so close to the bottom of the list that it's faster if you hit the up arrow. And like, does that make sense? Like go the opposite direction, hit up, and you should see something that says log base. Do you see that? All right, so it's math, log base, and then type it in. Log base 2 of 7, boom. So what would we write on our paper for the appropriate number of decimal points? Perfect, 2.807. Let's try it again. Look at number 4. Do you see how the base is 4? Or, oh wait, hold on a second. Do I need to look at your calculator? Or are you okay with your calculator? Oh, just hit enter. Are you good now? Yeah, you just hit enter. So do you see how this is a base of 4? That means to both sides, we're going to log base 4 because they'll cancel out. That's the whole point. So the exponential base 4 and the log base 4 cancel. You have 1/3 x equals log base 4, 17. And then you have one more step to get x by itself. How would you cancel times by 3? So you're going to multiply both sides by 3, and I'll show you how to type it in the calculator. Go into your math menu and get your log base. Log base 4 of 17. And then outside of that, you're going to do times 3. The other thing you could do is put the 3 out front instead. It doesn't matter. But what you don't want to do is just 17 times 3. Let me show you what I mean. Like, this would be wrong. This would be wrong. Do you get what I'm saying? Like, it has to be outside. Okay. So times 3. 6.131. Do you see that? All right. Now this one, before I can do log base, do you see that 75 out front? It's being multiplied, so how do you undo multiply? Right. So you're going to divide by 75. 2 to the power 3x equals, now I don't know 225 divided by 75 off the top of my head, so I just typed it in my calculator. Keep the phones put away. Respect and stuff, all right? I just typed that in, it equals 3. Now what? What would you do to both sides? What is that? I heard somebody say it over here. Perfect. Log base 2, because it's going to cancel out with the exponential base 2. And you would get 3x equals log base 2 of 3. And then you have one more step, which would be what? Divide 3. So you're going to put that in your calculator. I see some of you type it. Is this going okay? Some of you are typing it already, like you're ahead of me. Now, I would do the alpha y equals and get the fraction bar. If you don't want to do that and you want to just hit divided by 3 at the end, it'll work still. But if you want to remember how to do that, alpha y equals will give you that fraction bar. Math menu for your log base. And you basically just type it the exact same way it looks on your paper. Like it should just look exactly how it does on your paper. Right? But if you wanted to do this instead, log base 2 of 3, and then at the end, divide by 3, it'll give you the same answers. How would we write that on our paper with the appropriate number of decimal points? 0.528. You want the first 3 that you see. Is everyone doing okay with their calculator? Okay. Because I don't want the calculator to be the issue. Do you see that 7 out front? How would you move that over? Yep, divide 7. Now you can type 2 divided by 7 in your calculator if you want to, but I would just leave it 2 7s. Kind of don't want to pick up the calculator until you really need to. Now, for this one, we did log base 2 because it was a base of 2. This one we did log base 2. This one we did log base 4. How do you do it when it's base E? It's, well, the base, okay, good. I'm glad you know what E is. It's 2.7, but I think I heard somebody say it, but I heard a lot of things at once. Your logarithm with base E is ln. Those are inverses of each other. So E and ln are inverses. So those are going to undo, they'll cancel out. You'll get 5x equals ln of 2/7. Perfect, before I could even ask, divide by 5. So everyone go ahead and type that in your calculator, bless you, and see if you can get the same answer. And again, you can either do the alpha y equals, or you can just hit divided 5 at the end. I suggest using this fraction bar though, because then you don't have to worry about parentheses and stuff. So ln is right here, it's kind of next to the 4. Do you remember when we did the PERT formula with our compound interest? We hit second ln to get the E on there. It's the same button. They put inverses together on the calculator. So if you notice, like squared and square root is on the same button, E and ln are on the same button. They put the inverses together. Alpha y equals enter. Alpha y equals enter will give you that fraction. And again, if you don't want to do that, you kind of don't have to. Just, you can put the divided 5 at the end. It'll work both ways. I just think this kind of looks a little bit nicer. But how would you type this one for decimal points on your, or type it? How would you write? Negative 0.250. You need 3. It's the first 3 that you see. So another method you can use, which we're going to need for this one, is to use your properties, which we did last time. So let's review them real quick. When you're multiplying, you add your exponents. When you're dividing, you subtract your exponents. All right, so those are your properties. So looking at this one, we're dividing. That means we're going to subtract. So you're going to put E, so you have to put those together. Perfect. 3x minus 1x is 2x. And now you're back to something that looks like what we did before. It looks an awful lot like problem number 6. So we'll get a shot at redemption on this one. What's your inverse for E? Perfect, good. ln, they'll cancel out. You get 2x equals ln 4. Divide by 2, slam that in your calculator. .693. Good deal. Now this last one looks super weird. The method, when you see something like that, if you look at it and you go, yeah, that's going to be a nope from me. Like if you look at it and you're like, oh, that just looks horrible. Your last method that you can do is called U substitution. I don't know why someone picked the letter U. That's officially what it's called, is U substitution. I guess you could use any letter of the alphabet you want. You don't want to use E though. But it's called U substitution. The point of it is you take something that looks really complicated and you make it look a whole lot simpler. That's the point of it. Okay. So for this one, we're going to let U equal the complicated part, which is the 6 to the x power. Do you see that in there? The 6 to the x power. Let U equal that. And then you substitute in. This first part will be U squared. Let that sink in for a second. But why does it make sense that it's 6? Perfect. 6 times 6, 6 squared is 36. Did you come with me on that? Okay. And then it would be minus 7U equals negative 10. And then that is really similar to problem number 2. What do we do next? Evacuate, yeah, add over the 10. Do you see how we took something that looked really complicated and we made it look a whole lot simpler? That's the point of it. Is it takes something that you're looking at going, what on earth? And it makes it like doable. So draw your 2 parentheses. It's going to split U and U. 10 would be, yep, perfect. They're both negative. So you get U equals 2 and U equals 5. Now here's the thing. We're not quite done yet. There's a little bit more because we found U, but what you really want to find is X. So then you substitute back in. So instead of u, we're gonna put 6 to the x power equals 2 and 6 to the x power equals 5. And I know I'm close to the bottom of the paper, but this is the last step. When it's 6, you do log base 6 to both sides. And so you're just going to type it in your calculator, log base 6 of 2 and log base 6 of 5, and it'll give you your two answers. These are going to cancel. So you're going to type log base, again, it's in your math menu, log base 6 of 2 and log base 6 of 5. I'm gonna pause there and let that like sink in for everybody. I tried to type it really fast so that I could get ahead of you and you can see it, but I'm gonna pause now and let you guys like catch up to me. I'm not gonna do a break because I want the extra time to be at the end, okay, for you guys to be able to start your delta math. So I'm gonna just keep on going, okay? So over here we have the logarithmic ones. You have to check these answers because you can't log a negative. So the exponential ones, anything goes, domain is all reals. For these ones, just make sure you check them. You can't log a negative. Actually, let's write that down. Can't log a negative. So just make sure you check them. Typically, if you get a negative answer, you have to dismiss it. Like usually that's the way this happens. And once again, I can do problems from now until the end of the world, and I can't do a problem exactly like everything that you might see. I always say that it is a disclaimer because I don't want you to be like, well, she didn't do a problem like this one. I can't do one like everything. You kind of have to look at it and see what you've got. Your first method is, what's the base? Good, for the first one, it's 2. Hold on a second, you're ahead of me. No, you're good. I love it when you guys are ahead of me. That means that you know what's going on. Just think of Megan Trainor. Okay, so this one, the base is 2. It would be 2 to the power -1 equals x. Wow, that was easy. All you have to do is 2 to the -1, which is gonna flip it 1/2. Good, that's it. If you're like, that's it, yep. A lot of the logarithmic ones are like that. If you just do what's the base, then you're good. So look at the second one. What's the base? It's 7 to the what power? 2 equals, and perfect. I would just erase that and put 49. And then you're practically done. It's like the answer falls into your lap. What would you do to both sides? Yep, +2. So you get 51. Now, some of these next ones, your method for them is going to be use your properties. This is what we did last time. The properties I find are the hardest section in this unit. And when I bring them up in AP Calc, it's like no one remembers. It's like everyone wants to repress this. Do you see this 2 out front? Okay, you're allowed to take that and put it back as the exponent. Do you remember that sort of from 2 days ago? Okay, cool, I'll take it. So you have log base 5 of x plus 2 squared equals log base 5 of 9. And then it's actually pretty nice because since they're both 5, what's going to happen? Yep, they're gone. So we're just going to set these two things equal. I'm not going to rewrite it if that's okay with you. How do you get rid of a squared? Now the square root of 9 is 3 and it's negative. Good. So you get x plus 2 equals 3 and you get x plus 2 equals -3. This is going well. And we're doing well on time. Good, -2. So this one gives you 1 and this one gives you -5 and you will have to dismiss that one. If you plug a -5 back into the problem, you will be logging a negative number and you're not allowed to do that. Not too bad, right? Okay. I'm going to just do one or the other of these because they both have a plus, so they're going to turn out the same way. Do you see that plus there? That means you multiply. You multiply, you add your exponents. It comes from your exponent rules. So we're going to write log. Oh, the base isn't written. What does that mean it is? Because that's going to come up 10, all right? And we're going to multiply those together. So you've done this before very successfully. X times X. Good. Now the outsides would give you minus 1x. The insides would give you plus 2x. So minus 1x plus 2. Good. Plus 1x. And then 2 times negative 1 is negative 2. Good. Why did we multiply? Because the adding. Good. Equals 1. And then I already asked you this, but what's the base? 10. It's 10 to the power 1 equals all of that. Wait, question, go ahead. We are going to have to factor, but after we do what? Evacuate. You're going to subtract over the 10 so that you get 0 on one side. That would make it minus 12. And I'm recording this so you'll be able to watch the last couple of them, okay? We only have a few more. And then you'll split that. And I'm going to leave that there just so that we can finish. But if you get a negative answer, what are you going to do? Yeah, just dismiss it. You just cross it out because you can't log a negative. Okay. And this one's going to be really similar to that one. With the plus, you multiply. All right. This one would be a different method. Sometimes you don't actually need any of this. Like literally just isolate X. Like just get X by itself. Sometimes that's all you've got to do is like just solve it like a regular equation. Like when you look at this one, how do you get rid of a plus 4? Yeah, minus 4. Like sometimes it's just as easy as like just solve it. Like literally just solve it. What's the base? E. It's e to the power negative 4, good, equals 2x. And then your last step, divide by 2. Now that you're going to have to put in the calculator. So let's walk through that together. I would do the fancy fraction bar, alpha y equals. You're going to do e to the negative 4. It's second ln. Do you see how for the ln button it has e right above it? We did this when we did the PERT formula. So second ln, negative 4, and then divided by 2. Going to be a really teeny little decimal because of that negative. I got 0.009. If you got an error, I will bet money on this. You typed the subtraction sign instead of the negative sign. This is the negative sign. This is subtraction. This is negative. You need to type the negative sign, the one that's next to the decimal point. I'm a genius. I've been doing this for so long. That's all. It is always negative signs. It is always negative signs. Always. I know. Are we all okay now? It's decimal point 009. Are we all okay? I'd like to do one more and then the word problem. Okay. And then we'll finish with that. Do you see this plus sign here? See the plus? That means good. Thank you. That means you're going to multiply. So put ln. We're going to multiply them together. 2x plus 1 times x. Basically, you can just distribute the x through there. What would that give you? Good. Perfect. You guys are geniuses. Awesome. You know how to multiply and distribute and deal with exponents. Very good job. All right. What's the base? E to the power 0 equals all the rest of that. And what is e to the 0? 1. I'm going to just erase it and change that to a 1. So I don't have to rewrite the whole thing. And then this is like the 4th one we've done like this. Now what? Evacuate, you're gonna subtract over the 1 and then split it. Again, I'll finish that up and post it to Schoology, and when you get a negative answer, you have to get rid of it. Because when you plug a negative back in here, you can't log a negative. This problem is exceedingly weird. I would never put one like this on a test. Again, I'll fill it out if you're interested in seeing it. But when we had the plus sign here, do you see how we multiplied? When it's a negative, what are you gonna do? Divide. So I'm gonna just do the first step so you can see the property, and then we'll kind of stop. It would be ln of x plus 3 divided by x. And so it gets really weird with the fraction. Again, I would not put one like that on a test, so we'll just leave it there. As long as you know that the negative means divide, I'm happy. Okay. And then this one's about populations. Fairly recently, wasn't it just last year we hit 8 billion people? Cool. All right, in 1990, the world population was 5.3 billion people. The estimated rate of growth is 1.6%. Here's the equations. This is the equation we're going to use. T is time since 1990. So 1990 is your starting year, and our population is in billions of people. Here we go. What is the predicted world population in 2020? Do not plug in 2020. Oh, sorry, 2022. Do not plug in 2022 because we started in, so you have to subtract those. What time is it? Like, what are we actually going to plug in if you subtract those? 32 years. Okay. So all you're going to do is you're going to pull out your calculator and you're going to type this equation, but in place of T, you're going to put 32. Okay. The 5.3 E is second ln 0.016 times 32. Like you literally, it should just look like it does on the paper. That's how it should look on your calculator screen. And boom, you get an answer. So that's fairly accurate because we just hit 8 billion people, right? 8, but yeah, so I mean, models aren't perfect, right? They're estimations, right? 8.843 billion people. Yeah, we just plugged that in. Now this one's going to be backwards. That one we were given the time, we found the population. This one we're given the population, we're going to find the time. So we're going to plug 10 in, not for T, but for P, the population. So you're going to have 10 equals all the rest of that. And word problems have decimals, you know, that's, you get a calculator, that's your safety net, you're going to be okay. What do you think you would do first? Panicking is not an option. You have to actually do something mathematical. I'll give you a hint. It's something to do with this 5.3. What would you want to do with the 5? Good. You're going to divide by 5.3. And I would honestly just leave it as 10 over 5.3. You can type 10 divided by 5.3 in your calculator if you want, but it's going to look awful. It's going to be a crazy decimal. So I would just leave it alone. All right, then what? Again, panicking is not an option. You have to actually do something mathy. You want to get rid of the E. What cancels out E? ln. You're going to ln both sides. I always want to be thinking, like, how do I undo what's there? I want to cancel out what's there. So you have ln of 10 over 5.3, whatever that is, equals this awful decimal times T. And let me recap. We divided by 5.3. We did ln to cancel out the E. What's your last step? We'll divide by, yeah, 0.016. And then what you're going to do is type that in your calculator and then don't stop listening to me because there's actually one other thing we have to discuss, okay? And I would use alpha y equals for the fraction bar. ln, 10 divided by 5.3 and then over 0.016. We are going to actually round that to a whole number. And I'll explain why. But I just want to pause a second. Did you guys get that? So I'm going to say 40, but it's asking you for the year. So it's not like year 40. What year did we start in? We started in 1990. So if you do 1990 plus 40 years, it's the year 2030. So what this is predicting is in the year 2030, we'll hit 10 billion people. Thoughts on that?
They were wrong about the first.